Hello everyone, welcome to GMAT Friday one more time. This is your favorite series where we discuss difficult questions from all of the GMAT question types. Today we are here with data insights, specifically data sufficiency, whose question stem you see here. Now I've chosen this question because it's a hard question, 705 to 805 level with a low accuracy, 47% accuracy on GMAT Club. Actual could even be lower because this does include reattempts and attempts like those where people have seen solutions and answers and then marked. So let's see why this is such a hard question. What makes it hard? What are the parts? What are the elements that people get confused with? And how do we approach something like this so that we do manage to get to the final answer? Let's start reading this question stem first. So this is about Leah, who estimated each of the charges on her telephone bill by rounding the charge to the nearest $1. So multiple phone calls she made, every call was charged by the telephone company, so there were exact charges. So those charges could be decimal numbers also, but for the sake of estimation what she did was rounded each of these actual values to an estimated value, which is nothing but the nearest integer. If an actual is already an integer, well then it remains so. So here is how some of that would look. So if an actual value was $1.2, then what Leah did was she took it to the nearest integer, which is $1. So actually if you see the kind of rounding that is happening here, it's a round down where her actual to estimate that journey has led to a 20-cent decrease in the value. If you see the next example, $2.9 would be rounded up to $3, which leads to a $0.1 or a 10-cent increase as she goes from actual to estimate. So this is the kind of changes that are happening. Now, what are we really doing? Question is saying, was the sum of Leah's estimated charges, so all of the estimated charges were there and she added all of them, let's call that SE, was this within $8 of sum of the actual charges? So let's call this SA. Now what does it mean for one value to be within $8 of the other? What this really means is that, suppose there is SA here, the actual sum, whatever the actual value is. Was SE within $8 of this? That is, when I go $8 to the right of SA and I go $8 to the left, right and left means increase SA versus decrease SA, then this range that I get within $8 of SA, my question is whether SE lies in this range or not. Can it even be beyond this, or is it going to lie in this range? That's the question. Now you need to understand what this plus 8 minus 8 is. What is this? This is the overall difference between estimated sum and actual sum. But what is creating these differences? Overall difference is coming by these individual differences only, no? So suppose there were only these two charges, then you understand that going from actual to estimate, first there was a reduction of 20 cents, then an increase of 10 cents. If you see overall the movement that is happening, just add these up, you will see it's a 0.1 reduction. Which means if this is the overall only situation, only two charges, then the difference between these two, actual and estimated totals, that difference will just be a 10-cent difference. The minus is just telling you that estimate is lower than actual, but the difference is just the magnitude of this number, a 10-cent magnitude. So if same way you look at this, my question is really talking about whether the magnitude of deviation is less than equal to 8 or not. Magnitude should not be more than that. Whether I increase or decrease, that doesn't matter. Now each of these charges is what? A certain rounding. I can get some idea about what these values are going to be. But think about it this way. Each deviation that you have here, let's call that each small d. This is always going to be less than equal to 0.5 and it will definitely be greater than negative 0.5. Where am I getting this from? Just imagine what is happening, what kind of rounding are we doing here. Take an example. I am between 1 and 2, and then I take a value here which is say 1.9. 1.9 is the actual value. What is the deviation as I estimated? It's a 0.1 increase. That 0.1 definitely fits into this. If I show you the maximum increase there could be, then think about the value exactly between 1 and 2, which is 1.5. This time when you deviate, when you go to the estimate, it is an increase of 0.5. That's the maximum I've said. Why can't the positive be more than that? Well, because if I have a value here, I will no longer be increasing it this way. It's not like I'll go here and see what is the total increase. This time my nearest integer is here. So the decrease is what will start happening from here to here. Again, the decrease also will always be greater than negative 0.5. Why? Again, think about a value very close to this 1.5, but I want it to be less than 1.5, somewhere here. This one will decrease to become the estimate. And how much will this be? Well, if this entire thing is 0.5 and I will round up if I reach the middle, then that means whatever is the closest here, I can't really tell what that number is, but this is the maximum reduction I can see, which is slightly less than negative 0.5. Negative is just to show reduction, but it's a reduction by 0.5. So I am now sure that each deviation is going to follow this. It is going to be between negative 0.5 and 0.5, where 0.5 positive can be attained but negative cannot be. Just pause the video till here if you haven't understood this. Watch this part one more time. It's very important. Why am I talking about each deviation? Because ultimately I am interested in the total deviation, which is this thing here. This is what I want to see. Is it between negative 8 and 8 or not? So if I call my total deviation, like I just say it's total D, my question is total D between negative 8 and 8? This is your question. If you get a yes or a no from a statement, it will be sufficient. If you sometimes get a yes, sometimes get a no, then that statement will be insufficient. Now, I am interested in total, but I still have this information about each single deviation. And now let's see what the statements give us and how will we move forward with this. I'm going to take this and this to my first statement. Let's see the first. Okay, then here's statement 1. This says each of the actual charges was less than $7.7. Now, less than 7.75 could go all the way to, just a $0.1. I don't really know where any charge lies. So, I could have a charge which is between 0 and 1 or equal to these, which is between 1 and 2, all the way to the charges that are between 7 and 8. I know they are all less than 7.75. So all this statement tells me is that my charges could be anywhere in this range. Now, okay, I know it's here, but essentially I'm interested in the total deviation only, where each deviation I know will be this much. But how many charges do I have? It tells me about each charge, but how many are these? I mean, imagine a situation where I have 100 different charges and all of those are equal to 2.1. What happens in that case? You will have a negative 0.1 deviation 100 times. When you really do all of this, it's going to be a negative 10. This much is the deviation. Is it between negative 8 and 8? No, so I can get a no. But now imagine you have all of these 2.1s only, but you have only say 5 such charges. Then in that case, the total deviation will be negative 0.5. Is that within the range? Yes, it is. So this statement is not enough because it doesn't even tell me how many charges there are. Basically, knowing what the value of those charges is not important. I am always only interested in how much I am moving due to the rounding. Doesn't matter what the magnitude or what the value of an actual charge is. We don't care about that. So statement 1 alone is insufficient, because of which I am going to eliminate A and D. Now we'll go to statement 2. Alright, statement 2 says there were 14 charges on her telephone bill. This time it does tell you about the number of charges, even though it tells you nothing about the actual charge like the previous statement, which we found to be irrelevant. We really were interested in the number of charges since we have information about each deviation for sure. Now, think about the maximum deviation that could be there. So, maximum value of this total D. Think about it. Maximum is a 0.5. If I have 0.5 deviation all 14 times also, even then your total deviation is 7. And 7 is definitely in the range, which means the maximum I could increase is within the range. Even if you think about decrease, which is just slightly more than negative 0.5, think about what if it actually was negative 0.5, it would be a deviation of negative 7. But even this much will not happen because I can't really touch this value. I have to be slightly, negative 0.49 or something, which means this magnitude will be even less than 7. So actually what I get is that my total deviation is definitely between negative 7 and 7, and if this is a fact, then what can I say about this? Is it between negative 8 and 8? Absolutely it is. So I get a sure yes this time, a definite answer, which is why statement 2 alone is sufficient. I'll come back here to my choices, and since statement 2 alone is sufficient, I mark B as my final answer and I'm done. Very, very interesting question because there were so many layers that it had. It wasn't just, a very simple thing to do, so much to understand, so much to infer here. We really deep dived into what is this difference that I'm talking about. What does within $8 even mean? Where that $8 itself was not alone. It was made up of multiple small deviations, which we saw through an example. Take an example to explain situations to you. What is happening? What kind of values am I taking? And then once you realize it's really about each deviation and how many deviations there are, how many charges there are, therefore, that's all you care about. Statement 1 told you nothing about how many charges, therefore it told you nothing about the number of deviations. We only had each, while statement 2 exactly told you about number of charges and therefore number of deviations as well. So it ultimately turned into a situation where I only was interested in two things. So it ultimately turned into a situation where I was only interested in two things. I had an each deviation range which I multiplied by number of such D's, and that is what gave me my total deviation. It did not matter what the value of an actual charge was. It only mattered how the rounding bit worked, which is why we spent that time in the question stem analysis itself to understand what was happening here. If you don't deep dive, this is a difficult question. Very few people have been able to do it, and now you see why. Watch the solution again if you need to. Put your questions in the comments and we'll be very happy to help you. Make sure you follow the process. You go deep into stuff that you're reading. Don't just read to understand. It is going to happen for you. All the best.